With the applications of exponential models, okay, what we're talking about is investing money, all right? And what in the first problem example, we'll do 3 examples today about, number 1, having enough money to retire. Okay, that is, like I said, $500,000. Really sounds like a lot of money, but if you need to live off of $500,000 for 30 years after you retire, it really isn't that much. Because if you do the math, you divide by 30, figure out how much you have to have per year, and so on. So let's say in this problem, what I'm going to do is I'm going to invest $2,000. All right, we'll talk about retirement in example 2. I'm going to invest $2,000, and the rate that they're going to give me is 9%, which is actually very good nowadays. Let's call this 0.09 because you must convert all of your percentages to decimals. All right? And what I want to do, I want to ask you 2 questions. We'll call it A and B. I want to ask you 2 questions. How long is it going to take for your money to double? So if you invest $2,000, I want to know how many years is it going to take for my $2,000 to become $4,000? Now there's something about this. You are not allowed to touch your $2,000 during this time period. Do you think it's going to be worth it to take $2,000, set it aside, and invest that money to make it become $4,000? Do you think it's worth it? Mm-hmm. Depends on how long it takes, right? Mm-hmm. Okay.
How early can you start your 401k?
That's a very good question. You're going to have to sit down with somebody and figure it out. Because you know what? There are probably 60 to 80 investment profile types that you can start with. High risk, medium risk, low risk, high percentage, high interest, low interest. Do you want to invest it here in America? Do you want to invest it in the top 3 or 4 economies in the world like Brazil or India or Germany? Yeah, your money will grow faster, but it's a higher risk. So how long will it take to double? What do you want your amount to become? $4,000. $4,000, because if I'm investing $2,000, I want to know how long does it take for it to become $4,000. So let's take these 3 numbers, and the how long, okay, is the t value. That's what we're looking for. Your job is to find the time, and the time is represented in years. So here we go. A equals P e to the RT power. A is 4,000, and that's equal to P, which is 2,000, times E raised to the 0.09 times T power. And you will notice something that happens here every single time. If your money is looking to double, your value would be equal to 2. If you want your money to triple, your value would be equal to 3, and so on. Because look, when I get the E by itself and I divide by 2,000, this is going to happen every single time. You will have 2 equals e to the 0.09 t power. If you are investing $2,000 or $2 million, it would take the same amount of time for that money to double. I might invest $2. How long will it take for that $2 to become $4? It's going to be the same amount of time. Because you invest more, you get more interest. This is the amount of time that it takes for your money to double at 9%. Now, where is my variable? Where is my variable? It's in the exponent. How do I get the variable out of the exponent? You convert. And how do I convert with base e? Natural log of 2 is equal to 0.09 t power times t. So, take out your calculators, please. Real quick, these are simple questions. What I am going to type in is natural log of 2, push enter, and divide that number by 0.09. And this will give you the amount of time it takes for your money to double.
7.70.
7 point what?
702.
Let's call it 7.7 years. Kind of a long time, isn't it? Sounds like a long time, 7.7 years, but wait. You are not doing anything whatsoever. Why is that? Why does your money grow? interest, okay? The people that you give your money to, like the bank or like investors or like a financial planner, is going to take your money and it will invest it in bigger and better things, right? If I give you money, you can use that for a loan and you can pay me a little bit more back later on. So 7.7 years for your money to double. Sounds like a pretty good deal to me. And part B is this. How much money are you going to have after 18 years? So let's say you have $2,000 and you have a child and you want to take that $2,000 and you want to invest that money for your child, and in 18 years you can give all this money to your child and say, you know what, you can use it for college or books or room and board, or you can get it on a car for yourself or whatever. You.
So all you do is put $2,000 in the bank and just leave it and it keeps doubling? Or like adding more?
It keeps adding more. Interest is building and building.
Is it still?
Okay. Now what we're talking about here is continuous compounding. In a minute we'll talk about one that's not continuous, like monthly. Okay. If you have money in the bank across the street, you're getting monthly interest. All right. The bank's not going to give you interest every day or every minute of every day. It's every month. All right. So in that case, N would be equal to 12 because there's 12 months in a year. So my question is this. How much is going to be in this account after 18 years? Well, I'm going to use A per again because it's still continuous compounding. My p-value is 2,000 because that's how much I invested. And I'm going to multiply this by E raised to the 0.09 times 18 power. Please put your 0.09 times 18 in parentheses. That will give you the correct answer. Let me guess, somewhere in the neighborhood of $8,000? Maybe a little bit more? A equals $10,106 and 18 cents. Okay? Anybody in here would like to have $10,000 to use for college? I know I would. Because you know what? And remember, if you stay home, it is way cheaper.
And way stupider.
Okay?